A long-promised theory lies ahead of us. We will of course focus on the foundations, and we will start with the definitions, so that we know what we are talking about when we use a specific term. A term such as a repository, for example. The repository should be treated as the project database. We often use the repo shortcut. The repository is the history of our project states. This history covers all the commits we have done, and all the snapshots that were created as a result of these commits. We will talk about the snapshots in a moment. The repository also includes the commit relationships. We know which commit was previous and which is next. A certain structure of our project is created called the tree. The repository is stored in the hidden Git folder. We have already seen this in the practical examples. Commit is saving, sending, reporting to the repository the information contained in a commit. In this commit, we include the information about the files and the metadata. The commit also includes the structure of our project, what it looks like at this particular moment. The complete status of the project is saved in the commit, which doesn't mean that the commit saves all the project elements every time, because if the certain files have not been changed, they do not need to be saved again. We also saw that the files in the repository are saved independently of the commit. Commit only saves the relationship between these files and recreates the relationship when we need to refer to a specific commit. The commit can be treated as saving the new versions of the files. Every commit is made to be identified using a unique hash number. We've seen that. Each commit is also an object in our repository, as we have also seen. Of course, we can define what changes are supposed to be included in the commit. Not all the elements that we change in our working directory need to be committed. Snapshot. This is a term that many people working with Git don't use at all. This is in a way an abstract concept that tells us what a commit does. The commit saves the state of the project at a certain moment. It creates a freeze frame, or as it should be called, a snapshot. But many people skip the snapshot concept, considering that this is what a commit is. So a snapshot is just a concept that allows us to get an in-depth look at what is happening during the commit. We can tell ourselves that the snapshot is saving the full state of the project in the repository. This happens thanks to a commit, so many people use these terms as one. You may consider the snapshot to contain anything currently in our project. As you have seen, when the commit is made, both the commit object and the tree object are created. The snapshot contains both of these objects, so information about the files, author, date, relationship between the files, and the structure of our project. Now I want to tell you something about the three repository areas. We have a working directory, which is our workspace, a staging area, which may be called an index, and the hidden Git folder, which is strictly our repository. Our working directory can exist without Git as well, but from the perspective of Git, the working directory is the folder where the hidden Git folder is located. This directory also contains the files and folders of our project. The staging area is the intermediate state. It is physically located in a hidden Git folder. However, we treat it as a virtual temporary area for our files between the repository and the working directory. It is a place that stores the state of the project for us, which will be the subject of the next commit. We need to add files to the staging area using the git add command. This area contains the entire project record from the last commit. If you'll check the Git status in the console right after committing, you won't get any information, but don't think that the staging area is empty at this point. This area contains the full record of the project from the last commit, but it doesn't show you any differences. You get the information that there is nothing new in the staging area. There is no change from the last commit. If you will make any changes to the files, Git status will notify you of these changes, but these changes will refer only to your working directory. If you want to include these changes in the next commit, you have to add these modified files to the staging area once again. Remember that if you add a file to the staging area, This area not only consists of this one file, but also all previous files that have not been modified since the last commit. Hidden Git folder, which is literally our repository. We know that the repository in general includes our working directory and the staging area, but strictly the hidden Git folder contains the entire database of our project in the form of the objects. Let's talk about these three areas a little more. On this slide, you can see that the staging area and the repository are physically located in the hidden Git folder. And the working directory is the catalog where our hidden Git folder is located. So this is the main directory with our project covered by the repository. In the staging area, we have the elements to be included in the next commit. After executing the commit, the staging area is cleared, but it's not empty. It contains everything that was in the last commit. You just don't get the information about the changes since the last commit if there are no changes at all. The repository stores the history of the project, their states and metadata. I think it is already understandable to you. We also know that in the working directory we have the files that we are working on. We also know that the files in the staging area will be the subject of the next commit. And of course, we know that our repository stores the saved versions of the projects placed in the repository by the commit. If we make any changes to the files in our working directory, Git knows it. It tracks a certain file or it doesn't, but it knows what's going on in that area. Using the git add command, we move tracked and untracked files to the staging area. The versions of the files in the staging area, which are the versions at the time of executing the git add command on these files, are waiting to be added to the repository with the next commit. But before we do the next commit, we can still work with the files in the working directory, and Git will know that there are two different versions of a certain file in the working directory and the staging area. And the two versions of the same file don't need to be identical at the time of committing. In our working directory, we have our current changes, what we are working on. In the staging area, we have the changes that we want to approve in the next commit, not necessarily up to date. Any changes in the staging area must be present for us to commit. We can't do a commit if the staging area is exactly the same as in the previous commit. The files that have not been changed and are in the staging area, because we know that everything in the state from the previous commit is still in the staging area, will be saved as the references to the older versions of the files. Git doesn't needlessly save the same unchanged file several times. It just keeps a reference to a file saved in an object once. In the repository, we have the changes committed and stored in the Git database. As you know, Git stores the project data as the objects. For example, you can create a file with my name, and when executing the git add command, an object containing the information about this file will be created in your repository. Even before the commit, every file tracked by Git must be saved as an object. Later, you can review the content of this object and you will see this effect if you created this file in PowerShell, because bash and git bash may encode saved objects differently. Now let's focus on 4 states of the files in the repository. Be aware that this is a simplification of some kind. This is not an official file state breakdown. There are various methods of identifying these states. Nevertheless, I adopted such a division because it explains well what is happening to a certain file in a certain state. The first state is the untracked file, when we create a new file. Of course, we can also delete the file from the tracked files. When we use the git add command on the untracked file, which is adding it to the staging area, it becomes tracked and takes one of the other 3 states. When we add a file to the staging area for the first time, it has the status of tracked staged, so waiting to be saved to the repository in this state with the next commit. An unmodified tracked file is a file that has already been added to the repository with a commit before and has not been changed in the working directory since then. We won't see such a file using git status command, although it really is in the staging area but has not changed since the last commit. The last state of the file is tracked modified. It applies to the files that have been modified in our working directory. Such a file, after modifying, is not automatically added to the staging area. It has only been modified in our working directory. To save the changes to this file in the next commit, we have to add it to the staging area once again. So really we are only interested in 3 file states: untracked, tracked modified, and tracked staged. Because we will only see the information about these 3 states using the git status command. Tracked unmodified files are stored in our staging area, but are not visible for us because they haven't changed since the last commit. We can assume that there is also a 5th state, ignored file, when we don't want some files or folders to be tracked and saved to our repository. We only want them in our working directory. This only applies to untracked files. Git does not consider such files as if they were not there. We won't get any suggestions about possible actions considering these files or any information about their modification. To ignore a specific file or a folder, we need to create a git ignore file in our working directory and enter the name of a file or a folder we want to ignore. Let's go through the whole process of changing the state on the example of one file, index.html. I created 2 files here, index.html and style CSS. I'll be concentrating on changing one file so we can see exactly what's going on. At this point, while creating these 2 files, Git knows they exist. At the bottom of the screen, the status of the index.html file at a certain time is marked in yellow. As we can see, it is currently untracked. Now we use the git add index.html command. We indicate that this file is to be moved to the staging area. Moving to the staging area also means that this file becomes tracked. So we can see at the bottom of the screen that our file is now tracked staged. It's worth remembering that such a file can also be removed from the staging area. A suggestion on how to do this can be seen in a console above the name of our file. Don't worry about the style CSS file. It will accompany us for the sake of clarity of what is happening to the index.html file. When we will do a commit now, our index.html will become tracked unmodified. And when we type the git status command in a command line, we will not get any information about this file. We only see the information about the style CSS file. Index.html file is still in the staging area, but hasn't changed since the last commit, so we don't see any info about it. After doing a commit, we modified our index.html file in our working directory. Now, after typing git status, we will get a message that this file has been modified. At the bottom of the screen, you can see that the status of this file is now tracked modified. These changes were only made in the working directory. So Git tells us that the index.html file, which is in the staging area in our repository, has a different content from the index.html file in our working directory. We can now also undo these changes from our working directory and restore the content of this file from the last commit. You can also see a suggestion on how to do this above our file name in the command line. Note that we have not added this new modified version of this file to the staging area. The file version in the staging area is the same as in the previous commit. So if we would want to do a commit now, we won't succeed because the staging area is exactly the same as during the previous commit. If we want to add a new modified version of this file to the repository, we must first add it to the staging area once again. Can a file be tracked, staged, and modified at once? Imagine such a situation. I have modified our index.html file. I have added it to the staging area once again, and now it's ready to commit. We can see it in green in a console. But after adding it to the staging area and before doing a commit, I have modified it once again in our working directory. We see such a file in red in our console. This is one file in 2 different states with the 2 different contents. This way our file can have 2 different states at the same time, be in 2 different versions with a different content. As you can see at the bottom of your screen, this file is in 2 states. tracked modified, and tracked staged at the same time. That's all for this video for now. In the next video, we'll cover the basic Git commands in more detail. So let's go.